So in this recording, we're going to be looking at solving trigonometric functions over a given domain. So what I've done is I've put my domain in degrees mode, which is in pink, and in that light red color, we've got our domain given to us in radians. So what we're going to do is work out the degrees first, and then we'll work out the radians. So when I'm looking at this particular question, what I like to do, or with any solving question with trigonometry, is think about how this would look in a right angle triangle. So for example, if we take a look at the first question, we're told sine of an angle equals a half. So I know that the numerator is representing my opposite length and my denominator is representing my hypotenuse. And the reason being, remember that sine requires us to consider the opposite length and the hypotenuse. So if I fill in what I know, so my opposite length here is going to be 1, my reference angle is just there. That means my hypotenuse is 2 and my adjacent length is going to be the square root of 3. Now, using trigonometry, we know that the inverse of sine of half is going to give us 30 degrees. And that means that this angle here is 30 degrees. Now, if I worked it out, or if I wanted to know what 30 degrees is equivalent to in radians, I'm just going to do 30 degrees times by pi divided by 180 degrees. And simplifying that, I get pi on 6. So my reference angle in degrees is 30 degrees, or in radians is pi on 6. So let's start by working out what sine of theta equals to a half is when it's between 0 to 360. So looking at our domain, or both domains, we know that that's one full rotation. So it's one full rotation of a unit circle. So what I'm going to do now is actually draw my unit circle, and I'm going to label all my points, all my axes in radians and in degrees. So just bear with me for 1 second. So now taking a look at our unit circle, we know the following properties. All are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. Given that my ratio is positive, we're going to be focusing exclusively in the first and second quadrant. So if I look at this now, I need to work out what this angle is here, and then obviously what this angle is here. Now, to work out what my angle is in the first quadrant, all I have to do is basically just do the angle. However, if I'm looking at the second quadrant, I actually need to work in a clockwise direction. And in degrees mode, that's going to be 180 degrees minus the angle, or in radians, that's like saying pi minus the angle. So what this means is for this particular question, we're actually going to have two solutions, whether that be in degrees or in radians mode. So in degrees, my first angle for sine will be 30 degrees. And my other angle will be 180 degrees minus the 30, which will give me the 150 degrees. Now in radians, again, we can expect two solutions. The first being pi on 6, and we found that when we were converting our 30 degrees into radians, or we could have also found that if we had our right angle triangle and we were working it out in radians mode. Now to find the second angle, I said previously we need to do pi minus the angle. So in this case, my angle is going to be pi on 6. So that means my other angle will be 5 pi on 6. And what this means is in order for sine to equal a half, the angle would either be pi on 6 or 5 pi on 6 when it's between 0 to 2 pi, or when it's between 0 to 360 degrees. My two angles that'll give me a half for sine will be 30 and 150 degrees. So now if we move down, again, let's have a look at another function. This time it's tan. So I'm going to start by filling in my right angle triangle. So we know with tan we're focusing on the opposite and adjacent length. So my opposite length is 1, my adjacent length will be the square root of 3, and my hypotenuse will be 2. So coincidentally, this right angle triangle is exactly the same as the one we did in question 1. So I'm just going to fill in that this is 30 degrees or this is pi on 6 in radians. So again with this one, we are focusing on a domain that has one full rotation. So we should be expecting 2 solutions in degrees mode and in radians as well. So just keep that in mind. We should have 2 solutions for both. So I'm just going to annotate the unit circle that we've got above, but I'll do it in another color. So this time we're focusing on when tan is positive. So tan is going to be positive in the first quadrant and in the third quadrant here. So to find any angle in the third quadrant, we can do the following. In degrees mode, we're going to do 180 degrees plus our angle. And in radians mode, we're going to do pi plus our angle. So focusing on the degrees first, we're looking at a domain between 0 to 360, so that's 1 full rotation. So my first angle is going to be 30 degrees, and my second angle will be 180 degrees plus 30, which will give me 210 degrees. So my 2 solutions for tan, that'll give me a ratio of 1 on root 3, will be 30 degrees and 210. In radians mode, we can do the following. So we know the first angle will be pi on 6. The second angle we can find by doing pi plus pi on 6, which will give me 7 pi on 6. Now, just in case you're wondering whether it's necessary to do the pi plus the angle, you could also have converted the degrees into radians. So we could have done 210 degrees times by pi on 180 degrees. Simplifying that, we get 7, and that's 6, and that'll give me 7 pi on 6. Alternatively, you could have converted the radians to find your degrees as well. So we could have done 7 pi on 6 times by 180 divided by pi, and that would simplify to 210 degrees. However, I do want you to start practice using the unit circle to find our angles as well. But just keep in mind it is a good skill to have to be able to convert between degrees and radians. Now moving on to the third question. So this one's going to require a little bit more work on our part before we actually go in and try to solve it. So what I'm going to do is start by actually moving this square root of 3 to the right hand side. So that's going to give me 2 times sine of angle theta is equal to negative square root of 3. Now dividing both sides by 2, that's going to give me sine of angle theta is equal to negative root 3 on 2. Now for the moment, just so we can fill in our right angle triangle, I'm going to say to ignore that negative. It is important that you keep in mind you do have a negative because it's going to become quite important when we try to solve. But for the moment, just to establish our right angle triangle, let's fill in what we know. So sine requires us to consider the opposite and hypotenuse. So my opposite length this time is root 3, which makes my adjacent length 1 and my hypotenuse 2. So this time my angle in here is going to be 60 degrees or pi on 3. So now what we need to do is go back to our unit circle. I'm just going to quickly label my unit circle. Alright, so now we know that in our quadrants we've got the following properties. So if we look at sine, we know it's positive in the first and second quadrant. However, we need to now bring back into the equation this negative. So because we have a negative, we're actually dealing with sine in the third and fourth quadrant, which means that sine is actually negative in both. So what that means for us is now we need to work out what the angle is in the third quadrant and what the angle is in the fourth quadrant. So again, looking at it in degrees, to find any angle in the third quadrant, we're going to do 180 degrees plus the angle, or we're going to do pi plus the angle in radians. And in the fourth quadrant, we're going to do 360 degrees minus the angle, or we're going to do 2 pi minus the angle if we're working in radians. So going back to degrees, so our first solution will be when 180 plus 60 degrees, which will give me 240 degrees. My second angle will be 360 degrees minus 60, and that'll give me an answer of 300 degrees. So for this particular solution, or for this particular equation, sine of 240 degrees will give me an answer of negative root 3 on 2, or sine of 300 will give me an answer of negative root 3 on 2. And the reason being that my domain is once again restricted between 0 to 360 degrees. So that's one full rotation of our unit circle. If we're looking at our answer in radians, so we're going to do pi plus the angle, which in this case will be pi plus pi on 3 for an answer of 4 pi on 3. And our other angle we will find, sorry, that should be pi plus theta, 2 pi minus theta, pi on 3, and that will give me an answer of 5 pi on 3. So in this case, my angles in radians will be 4 pi on 3 and 5 pi on 3 in order for sine to equal negative root 3 on 2.